In that first lesson, we looked at equations that really only required one operation to solve. Those were called one-step equations. And today we're going to take a look at equations that take more than one operation in order to get the variable by itself. So to isolate the variable means we want it by itself, which means anything next to it has to go. So the first operation is always going to be the same. The first operation is either going to be to add or subtract. And whenever we look at an equation, we want to first find out what is being added or subtracted in the equation. Take a look at this first example that says 3x minus 5 equals 19. And if you hear yourself say it, it says 3x take away 5 or 3x subtract 5. And so that's going to be our first operation, is going to be to get rid of subtract 5. The opposite of minus 5 is, you probably think about it for a second. Remember yesterday, the opposite of minus is plus. So we're going to be adding 5 to both sides, and that's our first operation. So whenever we perform an operation, we want to put a line and we want to sum total up what each side of our equation has. Don't forget the equal sign. Let's copy it down. On the right side, 19 plus 5, just like it is, we can count, it's 24. And this minus 5 and plus 5 over here, they turn to zeros. They're gone. We're not going to write the 0. But we are left with 3x. And now we are down to a one-step equation. This only requires one more operation, and that is we have to get rid of the 3. And so the second operation, if we come back up here, the second operation will always be a multiply or a divide step. So in this problem, it says 3 times x equals 24. And in order to undo times by 3, we're going to show divide by 3 with a little fraction line just like that. And the 3's are going to cancel, and that's going to leave us with x equals, and 24 divided by 3 is 8. And we'll box that answer up. Let's come over here. I see negative 2x minus 4 equals negative 2. And our first operation, don't do anything here. Our first operation is right there, minus 4. The opposite of the minus 4 is to plus 4. And remember, we got to do it once on each side of the equal sign. There's my equal sign. We did it once on the left and we did it once on the right. Copy your equal sign down. There's 1 plus 4 there. Negative 2 and a plus 4 is 2. And these, the negative 4 and positive 4s cancel out. But we are left with this. Please don't forget that little negative sign right there. We have on the left side negative 2x. And if you hear yourself say it, it looks like negative 2 times x. And the opposite operation or inverse operation of multiply by negative 2 is to divide by a negative 2. So we're going to draw a fraction there. Divide both sides by that negative 2. We'll cross these off because negative 2 divided by negative 2 is just a 1. And that just leaves us with this x. And on the right side, I have 2 divided by a negative 2. That is just negative 1. And we'll box it. I want to address this last sentence here. If a number could be substituted into an equation and made the equation true, we call that a solution. I want you to circle the word solution. Because when we find an answer and we box it, really what we're boxing is our solution. We're saying that if I put 8 into that first problem for x, that I would make the equation true. So this is what I'm going to do. I'm going to replace this equation, but instead of writing 3x minus 5, I'm going to write 3 times 8 minus 5. And I'm going to copy the rest of the equation down equals 19. 3 times 8 is 24. And 24 take away 5. 24 minus 5 is 19. And since 19 equals 19 is true, that means that when x is 8, this side of the equation on the left will equal this side of the equation on the right. That's why we call 8 a solution. Just the same way over here, if I replace this x with my solution, I should get a true statement. So negative 2 times x is now going to look like negative 2, and then I'm going to use parentheses, and I'm going to put a negative 1 in place of x. So negative 2 And then there's x, my answer, -1. And let's copy the rest of it down. Take away 4 equals -2. And let's just do the math. Follow the order of operations. The order of operations says we multiply this first. Negative times a negative is positive. So that's 2. Take away 4. And we want to know, does 2 take away 4 equal -2? And it does. 2 take away 4 is -2. And -2 equals -2 is true. Therefore, x equals -1 is our solution because it made the original equation true. Just like solving one-step equations, once you get used to the rhythm, all you have to do is recognize what you're trying to undo. Recognize that our first step is usually going to be adding or subtracting. And then you start to recognize what does add look like, what does subtract look like, what does multiplier. In this case, this shows x divided by 4 plus 1 equals 3. And this is the first thing we're going to be getting rid of is the plus 1. Our first step will always be the add or subtract step. And the opposite of a plus 1 is to take it away. So we're going to put a -1 there, and we'll put a -1 on this side as well. So once on each side of the equal sign, 3 take away 1, let's copy our equal sign down. 3 take away 1 is 2. And over here is x divided by 4 equals 2 because 1 take away 1, that went away. And now x divided by 4, the inverse operation of dividing by 4 is to multiply by 4. We put it up top just like that. And we multiply that also by 4. Notice I put it in parentheses. Sometimes dots get lost and I don't want it to look like 24. I want to make sure it shows 2 times 4. We cross these 4's off because 4 divided by 4 is a 1. And that tells me x equals 8. We can kind of do a little mental math too. Sometimes it's good to check the solution. If I put an 8 in here for x, 8 divided by 4 would be 2, and 2 plus 1 is 3, and that would make it true. Let's come over here to the second problem. Right away I recognize I have a negative sign here, and I don't want to lose it. Take away 5 is going to be the first thing I have to undo. The opposite of -5 is +5, so I'm going to put a +5 on both sides. Remember, we're always trying to isolate the variable, and we start with the plus or minus first. This is going to go away. Sometimes I'll cross that off, but I don't want you to forget what you started with. 1 plus 5 is 6. And this is negative x divided by 3. And I think on yesterday's lesson, we showed that this means we're going to have to multiply by a 3 to get rid of this, but I'm going to have to multiply by a negative to also change this to a positive. So we're going to multiply both sides by a -3. And if I multiply over here also by a -3, I'm going to 6 times -3 is -18. And the 3 cancels with the 3. And 2 negatives multiplied together at this point become a positive. So we really just wanted a positive x. And there it is. Positive x equals -18. Let's come down here. I recognize these last two both have a negative in front of the variable. So my last step is going to be dividing by, and I'm going to divide by something that also has a negative. Let's get rid of the +10 first. The opposite of +10 is to take it away. And I'm going to do it once on each side of the equal sign. Sometimes it helps to draw a line down the equal sign to help you separate the left side from the right side. That way you don't do 2 operations to the same side. That would be bad. -5 and a -10 make -15. And over here all that's left is -5x. So I'm going to go ahead and keep the -5x there. And the last thing I got to do is I got to get rid of this. Says -5 times x, so we're going to get rid of the -5 by dividing. So division is the opposite operation of multiply, and that said -5 times, so we divide. -15 divided by a -5 is +3, and that leaves me with x equals 3. And that's our solution. I can even do a quick check. -5 times 3, that would be a -15, and that would be a +10, and those two things together make -5, and that's true. So this becomes our solution. Last problem, we're going to add a 2 to both sides because I got to get rid of the -2. So I'll add 2 to both sides there. And this is going to go away. I'll just draw one little line through it. Don't forget the negative sign. That's a -x. Please don't drop that. negative x equals, and negative 8 plus 2 is negative 6. Now this is an interesting problem because this is the first time we've seen one of these, but in order to get rid of, we don't care about negative x, we want to know what x is. And the way you get rid of this negative is one way to do it is to divide by a negative 1. We didn't need to get rid of a number, there's just a 1 there, but it's really a negative 1. And the way we get rid of it is divide by a negative 1, because a negative divided by a negative is a positive. And that gives me regular old x equals, and negative 6 divided by a negative 1 is a regular old 6. And so x equals 6 is our solution. Here's one last two-step equation for this lesson. The first step is always going to be the add or subtract steps. The first step we're going to do is to get rid of that minus 2, and the opposite of minus 2 is to add 2 to both sides. But the reason I include this is because it's the first time we've seen a problem look like this. 1/4 x, that's how that reads, or 1/4 of x, or 1/4 of x equals, and 1 plus 2 is 3. This would be the same as if I had written it this way, x divided by 4 equals 3. And the reason it's the same is 1/4 is the same as dividing by 4. There's really kind of a 1 right there anyways, and now you can start to see what 1/4 looks like. And the way you get rid of a 4 on the bottom is to multiply. So we're still going to show multiply both sides by a 4, and then those 4s will cancel out. They'll become 1s, and you'll get 1x equals 12. I only showed that to you because this is the first time we actually saw a complete fraction out in front of the variable as a coefficient. So I wanted to show you how to handle a fraction if you have something like that.